All right, so real quick, let's just summarize for a second. We said yesterday that we are concave up when the second derivative is positive. We are concave down when the second derivative is negative, or when the first derivative is increasing and the first derivative is decreasing. Okay, so I want to talk about how that could play into extrema, maximums and minimums. Okay, so if something's concave up, right, it would look like this. Okay, and there would be what kind of extrema? A minimum. Okay, and if something was concave down, then it would be a maximum, okay? And that's where the second derivative test comes in, all right? Because if we've got this spot where we can find the concavity, if we know it's positive or negative, and we could find that other place. Now, in order for it to be a max or a min, what else would have to be true? It'd have to be 0 on the first derivative, okay? It'd have to be a 0 of the first derivative. And that's what the second derivative test says. If f prime is equal to 0 and f double prime is greater than 0, then x is where we have a local max. I'll call it a relative maximum. Okay, so if we know the first derivative is equal to 0 and we know it's, concave up would be a minimum. God bless it. Okay, so we know it's a critical point and we know that it is concave up, then it has to have a minimum at that spot. Okay, and that's what the second derivative test says. Likewise, the other way, if f prime is equal to 0, so we know it's a critical point, and f double prime is less than 0, meaning it is concave down, then x is where, or is the location of a relative maximum. Okay, so that's just putting together what we know about concavity. Okay, now we can't always use the second, what?
This was like my 7th grade field trip.
Is that a good or a bad thing?
Great.
Okay,
Loved that movie.
where'd you go?
Tremont.
Oh, fun times.
Like.
So it smells like outside?
No, it's like. It was like the dining area. But not during meals.
Okay.
I don't know, guys.
I was like, this a big thing. Okay, so we can't always use the second derivative test, okay? What might be some conditions or when we would want to use it? Any ideas? Well, what are the two things we have to know? Yeah, we've got to be able to take the second derivative so we can find the second derivative easily. And what else would we need to know? Yeah, we need to know the critical points. Okay, so a lot of times the best way to do extrema is using the critical points in the sign chart. Okay, in fact, 9 times out of 10, it's the best option. Okay, but if we have something where we're given, let's say we're given the critical points and we're given the second derivative, then yes, let's use the second derivative test. Okay, we've got the information that we need to do it. So let's do one where, we could do it either way, but let's do it with the second derivative test just to practice, okay? All right, so let's look at this one. So we want to find the local extreme values of f of x equals x cubed minus 12 using the second derivative test, okay? So the first thing we need to find are the critical points, all right? How are we going to do that? First derivative, so 3x squared minus 12, and what are we going to do with it? Set it equal to 0. So these are my critical points. All right. If we're using the second derivative test, what would be the next thing we need? The second derivative. Okay. So let's find f double prime. And it's an easy one. Okay. F double prime of x is just 6x. And so now, to determine if we have a relative min or a relative max at those critical points, we're just going to evaluate the second derivative at our critical points to know if it's positive or negative. All right, is it concave up? Is it concave down? So let's evaluate at those critical points. So f double prime at 2 would give me a positive 12, and f double prime at negative 2 would give me a negative 12. So what kind of concavity do we have at positive 2? Yep, it's concave up because that second derivative is positive. Okay, so if it's concave up, what are we going to have? A minimum. Okay, and then at negative 2, I get a negative number, so it's concave down, which means we're going to have a maximum. Okay, so we have a relative max at x equals negative 2. I'm going to write the explanation statement just so you've got one, because f prime at negative 2 is equal to 0, and f double prime of negative 2 is less than 0. Okay, so it's talking about the concavity. That's the justification, right? And then if we do the other one, we're going to have a relative min at x equals 2 because f prime at 2 is equal to 0. It's a critical point. And f double prime at 2 is positive, greater than 0. Excuse me. So concavity is useful, all right? It will tell me a lot about the behavior of the function, and so that's why we spend some time looking at it, okay, with that second derivative. Question about that one? Did I do better than yesterday? I got home, I told my husband, I said, well, today was a banner day. He goes, what do you mean? I was like, well, might have to do, 2 pages worth of work wrong, but it's okay. It's all right. He got a good evaluation on his bus. He loves that bus and driving a bus. Y'all, I cannot. I would, It's not for me. I'm so glad he likes it. He's convinced the little kids every time they see the police that they could take them to jail if they're standing up. And I was like, didn't. He was like, well, they see him, they go, 5-0, 5-0, and they all like get real still. I was like, okay, whatever. All right, let's look at this one. All right, so it says let g of x equal 2x squared minus ln of x for x greater than or equal to 0. Identify the x value of the critical point of g of x and classify that point as a relative maximum, minimum, or neither. Okay. Play with that for a second. All right, where are we stuck at? The what? Okay. What should we do first? Yeah, let's take the derivative. It's asking for the critical point. Okay. So let's take a derivative. We know g of x is equal to 2x squared minus ln of x. So that's going to give me g prime at x is going to equal 4x. What's the derivative of ln? Good, 1 over x. So we're going to set it equal to 0. Now, that's a little bit more difficult to solve. Would we agree? Yeah. Okay, so here's what I'm going to do. This is going to seem weird, but I'm going to actually move that 1 over x over so that I can solve a proportion. Okay, and remember, a proportion just says that cross products are equal. And so if I do that, I have 4x squared is equal to 1, or x squared equals 1/4. So then what would x equal? Plus or minus 1/2. Now, we have to be sure that we're reading carefully, because what does it say about my, my function? We're only talking about where x is greater than 0. So the only critical point that I'm going to consider is x equal to positive 1/2. Okay, I don't have to worry. And I also think it's interesting that it says up here the x value of the critical point. All right, so that was a clue too, that we might get more than one. All right, but we only wanted one. So I think that's interesting that they gave us that clue. Okay, now at this point we could do a lot of things. All right, but But I don't think it's too terrible to find that second derivative of that function that we've got right there, okay? Because all we're going to need to know is it positive or negative when we do it, okay? So let's do that. Let's find the second derivative. So if I have g prime at x equals 4x, and are y'all good if I make that x to the -1? It's just going to make my derivative easier, okay? So when I do g double prime, that's going to give me 4 plus x to the -2, or 4 plus 1 over x squared, okay? Now, the only value that I'm going to evaluate for is 1/2. So if I plug that in, g double prime of 1/2, okay, am I going to get a positive or a negative number? I'm going to get a positive. Everything's squared and added, so it's positive. Okay, so it's going to be greater than 0. I don't need an exact number. I just need to know if it's positive or negative. Okay, because if it's positive, what kind of concavity do I have right there? Concave up. Okay, and if it's concave up, what do we have? Max or a min or neither? We have a minimum. Okay, because it's concave up, we have a minimum. So we would say g of x has a relative minimum Mooney's in there working at x equals 1/2, because g prime at 1/2 is equal to 0. It's a critical point. And g double prime at 1/2 is greater than 0. Okay, second derivative test. Okay, there will be multiple choice. I'm getting ready to show you one. All right, and then I want to show you kind of how some of the free response stuff will look. Okay. Well, look, we're going to be done. All right, try that one. Ooh, gives me a table. Did you say I hate these? Oh, what? Okay, sorry. Give us. Try that one. I hate it when they put none. I go and buy all my syrup flavors at that, is it Bales, Bills, and whatever. So that's where I buy them all because they're cheap. They know me now, and so when I come up, the guy's like, "We got a new shipment." And so the last time I was there, he said, "Hey, we're going to unload the truck, and we just got a big box. We unload the truck, got a big box, and we're going to put them out on Wednesday." And I was like, "Great, I'm on my way." Like they tell me when they're coming, so I know when to come and look. They never know what they're going to get, so I always go in. Yesterday I got coconut and lemon blueberry cobbler. That sounded really good. I did not buy the maple bourbon pecan because I'm not a maple fan. But brown sugar cinnamon, that was my other one I got yesterday. Okay. Sorry. Do y'all like those cinnamon twists from Taco Bell? Okay. So, I can't have all that stuff. So they, I saw on one of my bariatric surgery groups that I'm in, where you take plain pork rinds and a little bit of butter and a sugar substitute and cinnamon, and you coat regular pork rinds in that fake cinnamon sugar, and it makes it like the twist from. I'm doing that this weekend. I didn't go get me some pork rinds yesterday. We'll see if it counts. All right, what do you think? C. Why do you think C?
Because h prime of x is 0, h double prime of x is 3.
All right. If we look at C, we're talking about at just x equals 7. Okay. H prime is 0. That means it's a critical point. Okay. And we have a relative maximum. Let's see. It would be concave down right there. Yep. So it gives us a maximum. C is the correct answer. Let's talk about why the other ones aren't true. Okay. Why would A not be true? Yeah, well, and it's not a critical point, okay? H prime at -4 is not a critical point, okay? So -4 is not a critical point, so that's not a candidate, okay? The only places we're going to have it. It also tells me that it's just selected values. So is this a closed domain or an open domain? Open, okay? So we're not guaranteed an absolute. Could happen, but we're not guaranteed that, all right? Then it says that it's concave down from 3 to 7. And I think that's probably the most confusing one, because if we look at 3 to 7, they stay negative and get more negative, but are we guaranteed that it didn't go back positive at some point? No, we're not, because they only gave me certain values and not all the values. So that's why C has to be the one that works, okay? So that's a way that they can test the second derivative test standard without making you do all the explanations. Does that make sense? Okay, question about that? All right, last one. Last one, best one. Okay. So it tells me that a function f is continuous on a closed interval from -4 to 4. Okay, that's probably important. All right, continuous on a closed interval. All right. Then it says the discontinuous function f prime with its domain is shown below. Okay, so this is a picture of f prime. So this is x, and this is f prime at x. All right. We want to find the x-coordinates of all local extrema and points of inflection. All right. Now, there are a couple of ways to attack this problem. All right. When I think of extrema, all right, I think of my critical points. And critical points occur where the derivative is what?
0.
Yep. Anything else? Could be an endpoint. It is a closed domain, so we're going to think about the endpoints. Yeah, where the first derivative does not exist. Okay, so we tend to forget that. All right, so when we think about the critical points of this, we are going to start with the endpoints because it's a closed domain. Then we're going to talk about where is this derivative equal to 0 or where is it undefined. Okay, so this picture that they've given me. So here we go. I'm going to actually set up a chart. Okay, so I got f prime and I've got f. So we're going to start at -4 and we're going to end at +4. Now, let's throw our critical points on there. Where is this derivative equal to 0? -3, -1, and 1. Okay. Where is it undefined? 0 and 2. All right. So everybody with me? Okay. So that's where we get our kind of our sign chart, so we can talk about increasing and decreasing and all that good stuff. Okay. Now let's go in and look. We want to know now, is the derivative positive or negative? So if I go from -4 to -3, is this derivative positive or negative? Positive. It's above the axis, so we're going to increase, right? What about from -3 to -1? Negative, so we would decrease from -1 to 0. Positive, so we would increase from 0 to 1, negative, so we're decreasing, and then from 1 to 2, positive, so we're increasing, and then from 2 to 4, negative, so we're decreasing, okay? Why is that important? What's it going to tell me if I know where it changes from increasing to decreasing? It's going to give me my extrema. Okay, it's going to give me my extrema. So let's go through it this way. All right, let's start with, because that's one of the things it asked me for. Let's talk about our relative maximums. All right, let's do between the endpoints, then we'll go back and talk about the endpoints. Okay, so I got relative maxes and I got relative mins. All right, if I go from increasing to decreasing, what's it going to show me? No. It's going to show me a maximum. Okay, it's going to show me, because we're talking about the first derivative. So the first derivative is going to show me a maximum there. So I'm going to have a relative max at negative 3. What's going to happen at negative 1? A minimum. What's going to happen at 0? Max. What's going to happen at 1? Min. And then what's going to happen at 2? A max. All right? But now let's consider those endpoints. Okay? And this is where it's hard. All right? So if we look at our chart, I have an endpoint at negative 4, and then my function increases. So what's going to be happening at 4? Is it higher or lower than the other things? Lower. So it's going to be a min at negative 4. Okay? And now let's talk about what happens at positive 4. Okay, so I got my endpoint at 4. My function decreases to that point. So is it higher or lower than what's to the left? It's lower. So it's a minimum as well. Okay, so you got to think visually about that. What's happening going into that endpoint, all right, or after, right? So that takes care of the first part, all right? Now we want to talk about the points of inflection, right? And this is kind of where I screwed it up yesterday, so I'm glad I'm getting a chance to walk back through it, okay? Our points of inflection are going to happen where my first derivative changes from increasing to decreasing and vice versa, okay? So points of inflection, all right, where f prime at x changes from increasing to decreasing and so forth, okay? So what I'm going to do now is let's look at this picture in those terms, okay? So if I start with my derivative, what am I going to do first in that derivative? I'm going to decrease until I get to where? At negative 2, okay? Then I am going to increase to positive 2, all right? Now, I'm going to increase to 0. But if I look at this other piece of 0, what does it still do? It still's increasing, so it didn't change, okay? So I decreased, I increased, and then what's happening right here? Constant. It's constant, okay? So the only time that we get a point of inflection is when it changes, increasing, decreasing, or decreasing, increasing, okay? So increasing to constant is not a point of inflection, all right? So how many points of inflection do I have? Just one, okay? So my point of inflection is at x equals negative 2, right? So that's all visual from the graph, okay? Is it necessary for you to write the chart down? No, but it helps me to organize my thinking, all right? That's what I failed to do yesterday. That's why I messed up, okay? All right, so I'm going to give you some practice, all right? It's all on the same page, and then we do have a wrap-up, all right, on this. Since we're going to be out tomorrow, claiming it, okay, we won't have a quiz on the first day back, okay, because I want to do the next section because it just kind of reiterates what we've been talking about, and I think you'll be better prepared for the quiz after that, okay? But you do need to do some of this practice because it's just, you just got to get in the habit of looking at the right thing while you're doing these, all right? And I'm going to go post the answer key here in just a second. 29, 31, 35, 37, 48. Okay, so I gave you several, and I'll put the answer key in there as well. Okay. okay? And then your wrap-up, this will all be, I think it's all on yesterday's, okay? So go in and look and go ahead and do your wrap-up for today so that you get that credit, okay?
Okay, so if we did school tomorrow, we would take this.
No, we would do the next lesson. We're not coming to school.
How confident are you?
How confident am I? I'm confident that on Tuesday they told my husband he probably wouldn't be driving a bus on Friday.
That's 100%. Apparently, they just told him to go up today even because they don't even think they're gonna drive tomorrow.
No.
Why don't we just go ahead and cancel because
I'm telling you, he's trying to do something cute.
It should just save us all.
That Arkansas guy, what's his name?
Scott Langford.
Yeah, he's trying to do something cute.
I think so.
what do you mean?
Like a cute video announcement or something.
I like me so cool.
I do too, but
Better
let's
than
just tell us
Langford
whoever.
is so slow on doing that stuff.
Yeah. I don't know. He likes to announce, like, if we're going to close for the next day, it's usually like 4 to 5 o'clock when he announces, probably because he doesn't want phone calls. Like, because they go home at 4:30. So that's my opinion. So I wouldn't look for it till this afternoon. I'll be surprised if it comes before we're out of school.